Hello everyone, my name is Harivansh Dogne and today we are going to discuss about the end-to-end data science project for British Airways. In this project, we built a complete end-to-end data science pipeline to analyze customer reviews of an airline, specifically British Airways. The goal of this project was to understand customer sentiment, identify key pain points, and build a machine learning model that can predict whether a customer will recommend the airline or not. This project starts from raw data collection using web scraping and goes all the way to predictive modeling and business insights. We begin the project with web scraping, where we use Python libraries such as request, beautiful soup, and CSV. The purpose of using the request library was to send HTTP request to the website and retrieve the HTML content of the airline review pages. Then, Beautiful Soup was used to parse the HTML content and extract meaningful data from it. We looped through multiple pages, specifically from page 1 to 40, in order to collect a large dataset of customer reviews. From each review block, we extracted several important features such as the customer's name, date of review, location, short, summary, full review text, rating, and verification status. We also extracted structured information like aircraft type, type of traveler, seat type, route, and various service ratings such as seat comfort, cabin staff service, food, and beverages in flight, beverages, in-flight entertainment, ground service, Wi-Fi connectivity, and value for money. The reason we extracted this data is because it represents the full customer experience. So the reason we extracted this data is because it represents the full customer experience. For example, textual review help us understand sentiment, while numerical ratings help us quantify satisfaction. Features like seat comfort and value for money are directly related to customer satisfaction, while recommended helps us define our target variable for prediction. This combination of structured and unstructured data gives us a complete 360-degree view of customer behavior. Once the data was extracted, we stored it into a CSV file. This step is important because it converts raw scraped data into a structured data set that can be easily analyzed using tools like pandas. After collecting the data, we move to the data analysis phase using libraries such as pandas, numpy, seaborn, and matplotlib. We first loaded the dataset and explored it using functions like .head, .tail, .info, and .describe. This helps us understand the structure of the dataset, the number of rows and columns, and the distribution of values. We found that the dataset contains around 4,000 reviews and 20 different features. During data exploration, we discovered that there were missing values in several columns such as aircraft, in-flight entertainment, and Wi-Fi connectivity. To handle this, we applied data cleaning techniques. Numerical missing values were replaced with the mean to their respective columns. While some categorical columns like location and seat type were cleaned by removing missing rows. Let's see that. We also removed unnecessary columns such as name, date, and route because They were not useful for predictive modeling. Duplicate rows were identified and removed to ensure data quality. Additionally, categorical variables like recommended and verification were converted into numerical forms 0 and 1, which is required for machine learning models. Next, we perform feature engineering, categorical columns. Let's see that. Here you can see that the categorical data. So this is a feature engineering. Next we perform feature engineering. Categorical features like location and seat type were converted into numerical format using one-hot encoding. This process transforms categories into binary vectors so that machine learning models can understand them. For the textual data, which is the full review column, we applied natural language processing techniques. First, we clean the text by removing punctuations and stop words using the NLTK library. Then, then we use count vectorizer to convert the text into a numerical format by creating a bag of words representation. This step transforms thousands of reviews into a matrix of word frequencies, making it usable for machine learning. After preprocessing, we move to exploratory data analysis. The histograms reveals that features had a bimodal distribution. Let's come towards it. So after preprocessing, we move to exploratory data analysis. The histograms reveal that most features had a bimodal distribution, meaning customers tend to give either very high or very low ratings, indicating strong positive or negative experiences. The box plot analysis showed that cabin staff surveys had the highest satisfaction levels, while Wi-Fi and connectivity had consistently poor ratings, making it a major pain point. The Let's come towards the correlation heat map. This is our correlation heat map. The correlation heat map revealed that value for money had the strongest relationship with whether a customer recommends the airline with a correlation of around 0.8. This means that customers are more likely to recommend the airline if they feel they are getting good value. Now, the pair plot further confirmed that higher service ratings directly led to higher recommendation probability. So this is our pair plot. This is our pair plot. The pair plot further confirmed that higher service ratings directly led to higher recommendation probability. The scatter plot showed that customers typically recommend the airline only when seat comfort and value for money are above average. The count plot revealed an important insight. More than 60% of customers did not recommend the airline, indicating an overall negative sentiment trend. After understanding the data, we built machine learning models. We used naive Bayes and logistic regression to predict whether a customer will recommend the airline. The data was split into training and testing sets, and the models were on the processed features. The naive Bayes model achieved around 86% accuracy, while the logistic regression model performed even better with approximately 91 to 92% accuracy. Here you can check the accuracy is 86%. This is our confusion matrix. This is our multinomial NB classifier. Here how we train an A-based classifier model. And then we perform the SS train model performance where we predict the output. Then we train and evaluate a logistic regression classifier. So this indicates that the model is highly effective in predicting customer recommendations based on review data. So let's come towards down. From a business perspective, this project is extremely valuable. It helps the company identify which services are performing well and which need improvement. For example, cabin staff service is a strong area, so the company should maintain it. On the other hand, Wi Fi, food quality, and in flight entertainment are weak areas and require immediate attention. The predictive model can also be used in real time to identify dissatisfied customers and take proactive actions, such as offering, let's see, such as offering compensation or improving service. This can significantly improve customer retention and brand reputation. Overall, this project demonstrates how raw data in the web can be transformed into meaningful insights and predictive intelligence. It shows the complete journey of data science from data collection to business decision making, highlighting how companies can leverage data to improve customer experience and drive growth. We can see it from the starting. Here in task 1, first we import the libraries and datasets, then we loading the dataset. Then in task 2 we explore the dataset. When we use df.head, we get all the headings of the top 5 indexes. Then we use df.tail for the last 5 indexes. Then here we get the info. Then we describe it. Count, mean, standard deviation, mean 25%. Then we check the full review column. Here we check the missing values. Then we check, do the total sum of the missing values. Then we come towards our task 3, which is data cleaning and pre-processing. Here we also drop the missing values in the column location and seat type. Then we drop the columns that are not useful. So now we don't have any missing values. Here we check how many duplicates exist. Then we remove the duplicate rows. After cleaning, we replace the columns by applying the function of lambda also. Then we drop some columns which are not necessary. Then we check the data frame. Here we check the all categorical data. Then we convert this categorical data to numbers. Then here we import the important libraries to change categorical data to number, for which we also use the scikit-learn one hot encoder equal to one hot encoder categorical data. Then we check the changes in data. Then we converting this new data to a data frame. Here we also import the string library. Here we import the string dot punctuation. Then we import the NLTK. Here we also use the stop words. Then we define a pipeline to clean up all the messages. The pipeline performs the following: remove punctuations and remove stop words. We also import the cont vectorizer. We convert all the data into the numerical form because machine understand the numbers. Then we perform in task 4 exploratory data analysis and visualization, where we first perform the statistical analysis. This is our box plot of service features. This is our while-in plot. Then we train a naive Bayes classifier model. Then we assess the trained model performance. After we done the precision recall emphasis scoring support, where we get the accuracy of 86%. Then we done the assignment under our task 7, which is train and evaluate a logistic regression classifier. From which we get the insight from our project. Overall customer satisfaction is moderate to low, with average ratings around the mid-range. Service related features like seat comfort, cabin staff service, and value for money strongly influence customer perception. Key pain points include food quality, in-flight entertainment, and connectivity services. So we get the model results, which is that the machine learning model achieved high accuracy around 90%, indicating strong predictive performance. It effectively distinguished between customers who will recommend and not recommend the airline. Key predictive features include seat comfort, service quality, and overall ratings. Then we done the recommendations. Improve low performing services such as food, entertainment, Wi-Fi to enhance the overall experience. Focus on maintaining high quality cabin staff service and comfort to retain customer satisfaction. Use predictive insights to proactively identify dissatisfied customers and improve retention strategies. So in this way, our data science project gets completed